Let's go. Hey everybody, and welcome to the SkyTour LiveStream for June 19th, 2018. I am your host, Mark D'Antonio, of course, and Amanda will probably not be joining us tonight. She had some things to do, but she may pop in, I do not know. Tonight we're going to do some asteroid hunting. So we'll be right to you in a short time, and I hope you guys are going to enjoy this. I'll talk to you soon. Hey guys, how you doing? I see you out there. Hey Maddie, hey Ted, hey Tana. I'm showing now on the screen the asteroid called Ceres. It's right there in the center, just a little above center. It's the bright one, a brighter one that you can see. Ceres is really a neat asteroid. It's the target member of the Dawn mission some years back, and there were some odd things seen on Ceres. Now we knew, excuse me, we knew going to Ceres that it was going to be a wetter asteroid than Vesta. And if you recall, we went to Vesta first. So it was kind of interesting that we went there. So Ceres is an asteroid that's actually 2.9 astronomical units from the sun. We're only one, if you remember. And at one AU or astronomical unit, we don't really get to see much further out without a telescope. That is to say, we can't really see details in the asteroid belt without a telescope, and that's what we're doing here. So I've got the deep sky settings set for Ceres right now. All right, so hey, look at that. Keith's here. Nice, Keith. Good to see you. Hope you guys are doing okay. I was telling him, Keith, that I'm showing Ceres, the asteroid, which is right there in the middle, just above center. And Ceres is 2.9 astronomical units from us. And Ceres is the largest asteroid in the solar system. But what you're seeing, though, in the middle, just above center, that asteroid is a brightness that we call magnitude 8.8. And by comparison, the sun is minus 26. The negative numbers are bigger. Vega is 0. So it's magnitude 0. So you can see how this goes. It's actually quite a drop. It's like each magnitude is 2.5 times dimmer than the previous. So it's pretty cool. Now I'm just gonna try and find. I was looking at Vesta earlier, and it's on the horizon. We're going to go to Vesta in a little while. We're focusing on the asteroids tonight because it's kind of cool to see these asteroids. And I'm just letting it flow as it happens. I just got back from Florida yesterday, so I'm a little tired. And the What on Earth Season 5 team was just here a little while ago and setting up for filming tomorrow all day. So I have to do that. So I'm pretty pumped that we got this to do now. We can check out the asteroids, and I think that these are going to be really neat to look at. Now, yes, they're just little dots of light, of course, but when you think about it, those little dots of light have really told us a huge amount of data. Okay, so when we look at our actual asteroid belt, you think, wow, there must be like a huge amount of stuff there. Must be a massive amount of asteroids out there. So you say, well, hey, how many asteroids when you add them all up? What do we actually get? How big of a what is it? How big of a planet or whatever could we get from it? And the answer would surprise you. The answer is you would only get a object the size of less than half the moon. In fact, about a quarter of the moon is all the asteroids out there added up together. Can you believe that? And it's true. So clearly we have a small number of asteroids out there. So that said, I think it's pretty interesting to consider what we're talking about here is just one small asteroid of many. And you'll notice that Ceres is probably getting a little dimmer. So that's because about half the telescope is behind the house and there are clouds around. But I just had to do this because two reasons. One reason is I wanted to show you Ceres, which was the eventual target of the Dawn mission. And the asteroid itself is, as we said, an asteroid known to be what we call a wet asteroid. That is to say, it has a lot of liquid in its soils and salts. And Vesta, the first target for the Dawn mission, is what is known as a very dry asteroid. It's arid, so to speak. Now, none of them have atmospheres, so that tells us something right there. Obviously, we're not talking about things that have atmospheres, but we are talking about having a system that has all kinds of asteroids and objects that are very much the epitome of what a solar system is for us, because that's all we know. For other solar systems, other star systems, I should say, we don't have any kind of data on their asteroids because we can't see them, at least not yet. But we did find rings around other planets, which is neat, and rings around other stars. And I did a SkyTour radio episode on those rings and their significance to us. And it's pretty good to go down that path when we did it, because that was a good point at which we had the understanding of how the asteroids are formed around our sun. Now, Ceres itself, as far as its size, it has, believe it or not, Ceres, that little dot you see above center, is an asteroid that has literally the 1/3 of the mass of the entire asteroid belt is in that one dwarf planet. And we call it a dwarf planet because it's not quite a planet. All right, it's not large enough to be a planet. So, and I apologize for coughing, but I don't know why that started. As soon as I hit stream, that started to happen. So I apologize for that. But Ceres actually has a thin, dusty outer crust. All right, it has a rocky inner core. And the core is actually rather large. It takes up a good deal of the planet. Perhaps just over half the diameter of the planet is composed. Is the core of the planet. And then beneath the rocky, dusty crust is a water ice layer in Ceres. And that water doesn't mean drinkable water. Of course, that means water mixed with other materials. And so we have salts and so forth. We know this because on Ceres there was a crater that had these two bright mounds, and those two bright mounds actually turned out to be salt deposits on the surface of the on the surface of the dwarf planet, and these mounds look like glowing dots together. When we looked at the crater, the Achator crater originally, and people got all excited because they thought, oh wow, these two bright dots on the surface of Ceres, does that mean there's intelligent life down there? Are they lights? Well, no. The problem is the way the telescopes take the picture. Ceres is actually pretty dark, and in order to take the picture of, and it turns out it was Achator crater, Occater, Achator. It's actually, those two dots were actually 40% brighter than the rest of this dwarf planet's surface. So that's why they look very bright. When they took a picture to get it, get the dark terrain to look right, it of course exaggerated the brightness of these the central peak and its associated salt deposits. So it's pretty cool. And now there's also on Ceres, the Dawn project also discovered this large pyramid-shaped mountain. And it's about 4 miles or 6 kilometers high, and about 10 miles or 15 kilometers wide at the base. And they called it Ahuna Mons. And it's the only mountain of its kind on Ceres. Now, before you leap to the conclusions that it's extraterrestrial in origin, keep in mind that the pyramid is a well-known natural shape. All right, it is a natural shape that occurs with they're on Mars, they're on the Moon, they're on Earth, and not the man-made, human-made ones. So it's pretty cool that Ceres has these really interesting features. So, hey, it's Dr. Mark. How you doing, Dr. Mark? Nice to see you here. Don't worry, I'll always repeat myself a few times to give you time to think about what's going on. So I just appreciate you guys coming in to say hi. And what I'm going to do is, after I wrap here, after we look at Ceres and a few other items, after I wrap here, I may go join Keith if he's still streaming, because it may not be. He's going to only be able to stream for a couple more hours anyway. So I just wanted to just let you guys know that this stream was sort of a last-minute decision, and I did this because the next asteroid that we're going to view, which is Vesta, is one that's actually above the horizon, of course, but it's also an asteroid that's very, well, shall we say, it's actually a very bright asteroid right now. It's extremely bright, as a matter of fact. It looks like if I just want to move Ceres down right to the center here. Okay, so there's Ceres. You're looking at it right in the middle now. And those red dots you see, we're actually looking at a live view. Okay, so we're actually looking at a 4K live view right now. So you're not seeing it. I'm actually recording this. This is actually a recorded recording as I'm recording as we're watching it. So if I shut that off, then this is how it looks. So you can see that we don't get a whole lot. And I'm going to take a picture of it, even though 8 seconds at whoops, that's too much. I said 40,000, so it's going to be all blown out. And there's definitely clouds over there. So I'm kind of doing this through the high clouds, and yeah, and that's what you get. Okay. So unfortunately, Ceres is going to have to, we're going to say bye-bye to Ceres for now. And if I just show you that live view again, you can see it's getting dimmer. And that's because of the fact that we have clouds and the telescope is winding past the house. However, those clouds will probably end our night soon enough. I just got started, wouldn't you know? But what I'm going to do is I'm going to go to Ceres. I'm sorry, I'm at there now. I'm going to go to a Vesta and show you how Vesta looks right now. Then we'll talk more about Ceres and Vesta. And I know you had some questions out there, but we'll get to them. I'm standing up down the dome, so I can't really see the chat at the moment, but go right ahead and put stuff in if you want to talk about it. Okay, I'm moving now to Vesta. Okay, and here we go. So we're moving down towards Sagittarius, the constellation of Sagittarius, because that's where Vesta is located right now. So as the telescope moves, and I've actually reduced the speed that the telescope uses, so it takes a little longer for it to get places. However, I think it's very important to do that because we really need to preserve the telescope and its drive gear and so forth. So the telescope will slow down here momentarily as it gets near location. There we go. Vesta in the sky. And Vesta is actually a lot brighter. In fact, right now, Vesta is the brightest it's been in a long time because of the way its nature is in its orbit and the way it's close to the sun from us, or close to the sun. So right now, we actually have Vesta in the view. Hey, Daryl, how you doing? Oh, don't worry, Daryl. It's no matter about being late. This isn't a class. No one's gonna, dock you or send you to the office. Right now, you can actually see Vesta right there on the left side of the screen, but I'm actually gonna bring it over to us more. Okay. Now you see that bright one right in the center? Yeah, say hello to Vesta. Those stars around it, by the way, there's a star to its upper right. Okay, that star is actually, let me get the magnitude of that star just to kind of give you an idea. Okay, it's the magnitude of that star is actually, let me get it now in my database. That magnitude of that star to the upper right of it, to the right of it, and just a little bit higher, that's a magnitude 11.7. Okay, so, and that's just a visual. We don't have to use a photo to take a picture of Vesta. Vesta is magnitude 5.3, and that star to its right that you see is the star. It's in the Tycho star catalog. It's TYC 6257-0183-1. Not that you even care, but that's just telling you. So that gives us an idea what that is there. And Vesta, right there in the middle, Vesta is really very interesting. It's not that it's not really that much closer than Ceres at all. Okay, but it's actually that it's just it's from us. It's well, let me get the distance here and just get all that stuff for you so that you can see it. I'm gonna just show that to you. Oh, sorry, I'm on the wrong thing here. I wonder why it wasn't showing. Okay, so let's go to Vesta again here. Okay, and now let's look at the information. It'll be very different. Okay, so so now Vesta is actually 1.1 astronomical units from us. Now the asteroid belt is actually it starts at just about one. Actually, starts out past Mars. Mars is at 2 astronomical units, and because of Vesta's orbit, it takes it inside of Mars orbit now and then, and we're looking at it right now at 1.1 astronomical units from us, and its brightness is really only 5.3. That's why it's so bright. It's also, it's the second largest asteroid in our solar system, so I think that also makes a big it makes a big difference as to how it will appear. So I'm going to look at the information here. It's 468 kilometers in diameter. Okay, all right. That's if you care about it, it's 0.036 Earths in diameter. Its mass is really not known. Its density is not known, but we do know that Vesta has what's called a differentiated interior. It actually has an interior that's got a mantle and a core, but they're not molten in any way. Vesta is a cold, dead world. So is Ceres, but Ceres actually has a ice sheath and has water and so forth. Now, what really stinks is that it was perfectly clear when I started this today, and now I'm looking out there and I'm seeing that suddenly it's as if the sky said, okay, he's got his stream going, quick, move in the clouds, and the clouds are coming. So I see Antares, I see Jupiter, I see the Scorpius, the Scorpion, Lyra. In the summertime, summer triangle, the constellation is wiped out. We don't see it, it's covered by clouds. And, the moon, of course, is out. So, when we're looking at asteroids, it's not that bad, because we don't have to worry too much about the light and the stray light and so forth from the moon. But looking at this here, and talking about this, asteroid Vesta, the Dawn mission went to Vesta first, and you looked at how the Dawn mission gave us a tremendous amount of information about Vesta. Now we suspected Vesta was dry as a bone, and that's exactly what it is. It's dry as a bone. We knew that, and the Dawn mission proved that. So we're okay with that. I'm actually going to take a photo just so you can see the field here that this is in. Okay, 8 seconds. I'm not going to do 40,000 this time. That was a mistake. I'll do 8 seconds at 10,000. Let's see how that looks. Okay, and this is now the Vesta star field, or the field with Vesta in it. Well, that's going to be a ruined shot because the dome is slightly in the way, and you can see the edge of the dome. So what I'm going to do is I'm going to move the dome where it belongs, and let's do this again, shall we? All right, let's do an 8 second again. This Vesta's kind of low in the sky, just so you know, so it's really tough to get a good shot of it, but we'll get a reasonable shot. Yeah, there you go. There it is, right in the middle. And now, just so you know, sorry about the noise of the chair. I put this, anti-fatigue matting in here in the dome, but unfortunately, it's got some ribbing on it, and so when you move across it, it does make that noise. So let's go back and look at the picture we just took. Okay, there we go. So right there in the center, the brightest thing in the view That's Vesta, the asteroid. And just above it is this little tiny star, okay? And that little tiny star is magnitude 9.6 to Vesta's 5.3. So there's the difference. You can see the difference. You know? So so I think that when we're looking at this stuff, we can actually see this. Now look at this. This is a whole star field, which is really interesting. And it's actually near, very near, another very interesting object. I'm going to point you there. And we'll come back to Vesta in a minute. I'm going to try and get a couple things in as we go here. But so I'm going to go over to it now. And it's only going to take it a second. And it's not going to change in the view because I'm actually hoping that the telescope doesn't get clouded out here. Hold on. Okay, we should be there. Okay, so I'm going to come out of here. And of course, you don't see anything. So I'm going to go 8 seconds at 10,000 again to show you this faint open cluster. And I'm sure it'll be there. No doubt. There you go. This is Messier 23, which is an open star cluster, and it's in Sagittarius. It's about 2,000 light years away from us, which is about 630 parsecs. If you know parsecs, that's 3.26 light years per parsec. So take 2,000 divided by 3.26, and you'll get 630. Now, if we take a look at this is an open cluster. It's actually superimposed over the Milky Way. You can't really see that too well here because it's way low on the horizon. But when we look at the stars inside there, one of the things you notice is that they have some different colors. See, there's an orange one there. There's some brighter blue ones and then an orange one. It actually has these two orange stars in the center that you see, and that's a pretty cool cluster. And that's Messier 23 or NGC 6494. That's in Sagittarius. And it's a 7th magnitude cluster, and Charles Messier discovered it in the 1760s. And it actually fills an area the size of the full moon. It's actually the size of the full moon. And if you've ever seen us do a stream with the full moon, you've seen that it takes up about that much space. So what does that mean? It means that the cluster has already started to disperse. Now, stars will form in these clusters like this, as I said many times. And then over time they disperse. They have orbits that they'll orbit each other. They'll fling each other out of the system, sometimes out of their presence and their association. And it's like I said, it's 2,000 light years. It's fairly good size, which means it's already begun that dispersal. All right, because clusters tend to be more compact when they first form. So it's pretty neat. And the diameter of what you're seeing on the screen from the left side of the cluster to the right, that's about 20 light years. So that's pretty good. So if we were to add up all of the stars in there and look at their intrinsic brightness, what we call luminosity, they would be over 6,300 suns bright. And that's because the hottest stars are B9 stars. That's why they look blue. Remember OBAF, GKM, the spectral classes of the stars go into making up the spectral type, where the luminosity class, which is the luminosity class is the Roman numeral 5, V, for the stars that are just burning normal hydrogen, actually fusing normal hydrogen into helium. Those stars are the ones that are in this cluster, and we're actually seeing some of the blue stars right now, and down below we actually see some of the stars that are actually a little more red. So that's kind of interesting, Now, as far as whether those stars that are down below, those may or may not be in this cluster. They could be foreground stars that are in the foreground, and the cluster could be in the farther background. So we'd have to get individual distances to those to get that figured out. All right, so that's kind of a neat thing. So we did Ceres so far, We looked at Vesta, the asteroid, and believe it or not, the Lagoon Nebula is actually way down south of this. But and just for fun, we can try to find it. I don't expect that it'll be any good, but it's sort of a little tease. It'll be a tease for the upcoming. It'll be a tease for the upcoming summertime. So let's go see if we can find it, just for fun. Yeah, it's gonna be buried down there. Well, found it, and it's pretty crazy. All right, you can see how the stars are actually. Let's just pull in here for a second. I want to show you this. You can see when things are near the horizon, you can see what happens, right? Look at the stars. Let me bring one over. Okay, check it out. See how they seem to be alive? They seem to be fluctuating in their brightness. We're doing a close-up view here, so if I go even closer, you can see that. Look at that. They're doing that dance. This dance is called atmospheric scintillation, and that word scintillation is spelled SCINTILLATION. It's an effect caused by the turbulence in the atmosphere with point sources. Point sources are how stars always appear to us, as little tiny points of light because they're so far away. So these point sources look like that. And when they look like this, they will dance around because the slightest thing can upset the apple cart of these stars. So, that said, I want to take us to an 8-second exposure of the Lagoon Nebula here at 10,000 ASA. Now we suddenly got some music there, didn't we? There it is. It's on the lower left. I'm going to just drop the music a little. Okay. So you can see the lagoon, which I'll bring back here now. Sorry, I'm coughing. There we go. Welcome to summertime, folks. Actually, you know what? I kind of moved that over, didn't I? So I'm going to bring us back. Bring back the lagoon. All right. Now I'm going to do in 10 seconds at ISO 10,000. Here we go. So we're taking an image now of the Lagoon Nebula just because it's fun. And I think it'd be kind of cool that we do this. I haven't done that for a while. Not since last summer, as a matter of fact. So let's take a look. Ah, there we go. Look at that. That's beautiful. I'm sorry. You can't take away from the lagoon how beautiful it is. And actually, for something that's really close to the horizon right now, doesn't look half bad. You know, doesn't look half bad. Let me close in, and we can actually see that little hourglass-shaped nebula in there? To the right of it, that star is actually an O star, the first one in the highest brightness star there are. The O stars, the massive stars. They're the hottest. And that one star is responsible for lighting up that hourglass section and a whole bunch of other areas in this nebula. It's pretty impressive. Really, really impressive. So, so Lagoon Nebula is a really interesting feature. Like I've told you many times, we've talked about it and looked at it. And I know that you guys have heard me say it, but I'm chasing areas of sky where there's no clouds, if you haven't figured that out yet. So let me just do this. All right, cool. Now, as far as Lagoon Nebula, okay, it's also known as Messier 8 or NGC 6523, but it's also known as NGC 6533 because it has several features that are prominent. It's actually 4,300 light years away, that beastie right there. And just for fun, let's go take a look at this at live mode and see how long we could go here. I'm going to increase the ISO dynamically now in our 4K view and bring the nebula up. Okay, well now you can start to see the nebula. And we're at ISO of 160,000. So let's go to, okay, this is 204,000. You'll notice the graininess. That happens because of the increase in sensitivity. It also increases noise. And if we go a little more, okay, this is 256,000. That's about as high as I dare go. I mean, if I go higher, okay, it actually starts to get washed out by other things. But to your eye, it would actually look like it's a faint patch in a dark sky. Not this dark. I'm just going back to what we had for settings. Let's do a 10 seconds at 20,000 ASA sensitivity. So this was, it was Giovanni Battista Hodierna, and he's the one that actually looked at this. See, we have clouds now. Yeah, there's a cloud sitting right over it. So that didn't really work out too well. And he actually looked at the Lagoon Nebula for the first time. It's one of the earliest, I should say. And he called it a nebulosa, which is actually kind of interesting because it was a, let me see here, we get this. I go here, not that. There we go. He called it a nebulosa, which is interesting. And it was also called a nebula by John Flamsteed, who did a lot of star classifications as well. Many stars have a Flamsteed number. So that said, it was another astronomer later, Philippe Loys de Chasseau, in 1746, that he actually got it to look like stars. You can see the stars in it, because otherwise it was just a fuzzy spot to folks. See, you got to keep in mind the telescopes were not all that good. But then in 1764, when Charles Messier found it, he described it as a cluster, and he mentioned the nebula separately, all right, as around the star 9 Sagittari. Now, 9 Sagittari is a star that was labeled 9 Sagittari. Sometimes we label them with numbers. So we see that here. I'm going to take another 10-second photo at 20,000 to see if we can actually snag this out of that cloud. I don't know if we will. Yeah, okay, there we go. We got a little bit of it again. You see how that was crazy? Check this out. So a little bit of a cloud gave us this. Look at the difference. Okay, there's the nebula, and there it's not. The same field. Look at that. Look at the difference. Okay, light cloud, no light cloud. Big difference, and it's near the horizon. I'm really impressed by this. It's near the horizon, but boy, look at that. Does not look bad for being near the horizon, I'll tell you that. We have, of course, we've got plenty of, problems with the image. It's not stable. It's not stabilized. The stars are bloated, but that has to do, of course, with the fact that the telescope is trying to look at something that's very, very low, and we're actually looking through more atmosphere. And when we look through more atmosphere, the images get both reddened and more unstable. Why reddened? Well, the blue light coming from the sun in the red, orange, yellow, green, blue, indigo, violet, otherwise known as Roy G. Biv spectrum from the sun, the blue likes to get scattered. So the more light, or the more atmosphere we look through, the redder the light gets. That's why when the sun is on the horizon, it looks red, because most of its blue light has been scattered by all the air in between you and that far distant location on the Earth through which you're looking through all that atmosphere. So that's what happens. And right now, the lagoon is looking inordinately orange, believe it or not. It is a red nebula, all right? But the problem is, as red as it is, it's made an unnatural shade of red. If you recall last year when we looked at the nebula, the lagoon, we noticed that the nebula was actually more of a bluish purple in the camera. Now, that was an incorrect color. But the fact that we're looking at it through more atmosphere tonight shows us that it actually kind of looks more correct. So it's kind of a funky little development. But anyway, this is a this is a really fun nebula, and we're certainly going to see more of it moving on. I also have a spectral system mounted on the telescope right now as well, and I've been trying to get it to do the HDMI out so that I can show you what it does. But unfortunately, we're not able to. It doesn't want to play nice. Now, though, I think there's one more thing we can show before we go tonight, because this is something that I think will be much appreciated, and that will be the moon. Why not? So be prepared for your eyes to get blown out a little bit, because the moon's going to be bright, and we are going to go find it. Are you ready? Me too. Here we go. And as I said, the telescope, I've got it running at what's called a slower slew speed, SLEW, slower slew speed, because I want to preserve the motors in the telescope for as long as possible, because I don't want to have to replace them ever. So let's go to live view here, say goodbye to the lagoon, and it'll be back, I promise. We're coming up on the moon now. Oh boy. Whoa. Hey, that music was perfect. Let's just do this. Let's get this. Let's change the settings of the of this here right now. Let's go down to an ASA of 50 for the live view, and let's also change the exposure from something like 20 seconds down to something reasonable. All right, we're approaching first quarter with the moon, so we can see clearly that the moon fills about this, and this is why I wanted to show it to you, actually, part of it. The moon actually fills about the same amount of space, remember, as M23, that cluster we looked at earlier. Isn't that cool? So I think that this shows us a few things that are of interest. It tells us that the moon is actually an object that we know is about a half a degree in size, but M23 is also a object that's half a degree. I'm sorry, in size. So it's the diameter of the full moon. So if you go from top left to lower right, just about, except I got to put it down just a little too much. Now you can see that just about there is the diameter. There you go. So now we can see the full moon. That is to say, the full size of the moon from upper left to lower right. Okay, and now that's pretty cool. I'm really liking that. Now let's see here. All right, now we got the moon in there, and what I'd like to do is talk about the moon if I can. All right, so we're looking now at some really cool details in the moon. That near the top, okay, you see that crater? Well, that's funny, isn't it? Hey, near the top of the moon, see that crater? Crazy. Let me actually zoom in for us since we're going to talk about the moon a little bit. Let me just give us something to see that's a little more than the other. I could do that, but I'm going to do it double like that, so I can actually move it around. I've been using two new systems to operate the telescope in the dome, including one that's a little better in some aspects and a little worse in some others. So I'm using that method now to move my scope around, and it looks like it's doing okay. So what I'm going to do is I'm going to move us around a little bit. There we go. All right, now we're looking at the top of the moon, the upper area of the moon, and we can see some really interesting craters up there. All right, and I'm really interested in showing you those craters. I'll tell you why. That crater, that one that's up near there that we're looking at, kind of in the center now, that bigger one, that's actually in the middle of Mare Frigoris, and here come the clouds. And that first crater you see, that bigger one, that's actually Aristoteles. And then down below it is another crater, which I actually 3D printed, and that's Eudoxus crater down below. And I may have to up the settings on the camera just to be able to see these, but maybe not. Now, to the right, all right, to the right, those two craters up there, those guys are Hercules in the lower left and Atlas to its right. Atlas is a little bit bigger. So that's pretty cool, and then down below, right there, you see that big crater. And you can see right there, that big crater. I'm going to kind of center it up here. Okay, that big crater right about there. That one is actually a very interesting crater that we know. We actually saw this crater before. We talked about it. And it's called Posidonius. All right. And then next to Posidonius, right to its lower right there. Okay, you can see it just to the right of Posidonius in the center there. That one there is actually a crater called Charcomac. And these craters are, of course, various diameters naturally. And what I would do is tell you that, say, Posidonius, for instance, okay, the crater is 95 kilometers across. It's sort of a circular crater. It's named for Posidonius of Apamea, which he was a Greek geographer, which is kind of cool. And I like a little bit of that. Now, going up to Hercules again, when we go to Hercules is up here, and I'll center it again, right about there. Okay, so Hercules is centered right there, okay? And Hercules is about 69 kilometers in diameter. You see there's a central peak there. It looks like a central peak. That's actually another crater, not a central peak, just so you know. And it's, like I said, 69 kilometers across. And of course, it's the Greek mythological hero Hercules, for which it's named. And Atlas is interesting too, because Atlas is to its upper right there, the bigger one. And it's bigger, all right. It's 87 kilometers in diameter, and it's actually it's actually quite a interesting crater, because it's of course the mythological Greek Titan. And I was looking at Daryl's comment. Yeah, Daryl, I'm trying to figure out a way to do like the Madden, like football, the Madden overlay thing. I downloaded an application to actually do that, so I'm learning how to use that, and it should work. And I'll be able to point these things out on the screen soon and do these. But right now, I'll just center the objects because I'm not going to pick something so hard that it's going to be truly difficult to see. For instance, okay, now if we go, if we look, let's see here, if we go down below. I mean, there's so much here, Down below, centered in the screen now, right? And actually, right next to Posidonius, okay, that entire darker gray area, which is just coming into light now, around Posidonius, which is in the center. Remember, that is actually Mare Serenitatis. Okay. And Mare Serenitatis is a fairly extensive sea. It's actually 707 kilometers across, and that's the Sea of Clouds we're looking at right here. No, Sea of Serenity is Mare Serenitatis. And the whole thing overall is, like I said, 707 kilometers across. So working on that, trying to get this figured out. But I've been trying to go down the terminator here, the moon, for now, and to see what we got. Okay. Now down below Posidonius, okay. I'm trying to. I gotta wait for the clouds. Okay. Do 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 do. It's still your turn. Do 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 do. Sorry. All right, there's a crater. You see that crater right there in the middle there? Okay, that crater. If I don't miss my guess, I think that's Plinius. That might be Plinius sitting out there in the middle. Yes, it is. That's Plinius, and then there's a little tiny crater to its right and to its upper right there. All right, so you see right out there in the center, in between in the gray area, you see Plinius, and just above it, tiny crater that's only literally about a quarter the size of it. That's Dawes. And Dawes is actually, a crater named after William Rudder Dawes, all right, the British astronomer who lived in 1700s to 1800s. And he was incredible. Now, Plinius, on the other hand, is, of course, named for Gaius Plinius Secundus, the elder, that is. And he was a Roman natural scientist who lived from 23 to 79, when the years weren't even 100. So that's pretty cool. I got to tell you, it's fun to take these little tours of the moon. Then we have these a promontory of rock and highlands right below Plinius there and to the left, and those are actually called it's called Promontorium Artrusia. Sorry. And then we have at the bottom of that. Well, we can't really tell, but we have a crater. It's almost right on the terminator there. All right, and that crater that's almost right on the terminator is right there in the center now. That's actually a crater called Menelaus. All right, and it's pretty cool. There's actually a volcanic feature not visible here, named after it, called Rima Menelaus, and it's right near it. But that's pretty nice. And then to the lower right of Menelaus there is another crater that looks sort of like it's kind of extended a little bit, like it has some kind of extension to it. That's actually it's actually a crater called Auwers, and it's named after Georg Friedrich Julius Arthur Auwers, a German astronomer who lived in the 1800s to 1915 or so. All right, and that's really nice. That's sort of a nice crater to look for when you're looking at the moon. And you notice I don't have it. I'm not magnifying too much, because if I do, then we will end up losing some of the features, because the moon is actually, has clouds that it's going through, and it's kind of a problem. So if we come down from to the lower left here, okay, right there centered in the view right there, okay, right below those little highlands you see, okay, there's a little crater right below a dark horizontal line that you see. All right, and that crater you're looking at is actually the crater Julius Caesar, believe it or not. And of course, there's no need to tell you who he is. He's the Roman emperor who introduced the Julian calendar. Okay, so anyway, that's a crater named after him, and so now we have more craters visible as we move down the terminator here, and I'm trying to find them as we go here. I think that I'm trying to figure out what that one is there. think that one is actually called Delambre. I'm not sure. I'm looking. I'm trying to figure it out. Maybe not. There's a double crater there. Okay. Okay, I think I got it. Okay. Yeah. All right. Right in the center, actually, above Delambre, which is that one with a dark shadow right in the middle of it. Okay. You see two craters that are kind of side by side. And those are Ritter and Sabine. They're right next to each other, and they kind of look like a pair of eyes. And it looks like Delambre with the black shadow looks like somebody going ooh when you use those as his eyes. So it's kind of cool. I like that. But this is like I said, we're just going exploring the Terminator because we can. It's kind of a neat thing to do. And I wanted to also just take us to one other crater here that we have in the moment. These two craters, actually. Those bigger craters, that one that you see right there in the center, is not quite in the center yet. Okay, it's in the center. Okay, that one, that's the upper one, is a complex crater, and that one's one called Theophilus. And Theophilus is, like I said, a complex crater. It's 110 kilometers in diameter, named for Theophilus, the Greek astronomer. And that particular crater, being complex, is one that hit after the one below it. And that one below it is Ceres, right? Ceres is an older crater, and you can see how the rim of Ceres has been obliterated by the impact of Theophilus. It actually made it basically put its own crater wall over Ceres' crater wall. So I think that's pretty interesting. Oh, sorry, Daryl. Yeah, I know it's like one of the few craters with the central peak visible like this at this point in the moon's cycle. But we can't remember everything, right? We're trying to be smart. We try to be smart, but sometimes we just don't have it, Now down below here, below Ceres, we see this crater that actually kind of has like some kind of little connection back up to Ceres. That connection is actually a valley that's also part of the wall of this crater that we're looking at right now in the center. And that crater we're looking at in the center, which is under Theophilus, above center and above and below. I'm sorry, below. Okay, let me say this again. The crater we're looking at in the center, okay, is below Theophilus, directly above it, which has that central peak, and it's below Ceres, all right, and that crater is called Katharina, and Katharina is actually a 104 kilometer mile diameter crater, and is named for Saint Catherine of Alexandria, Greek theologian, philosopher. So it's all these have these wonderful names, and I'm really interested in how all this stuff transpires. And by the way, that is all near the Sea of Nectar, which is right there in the whole center. There, it's that smaller round Maria, that smaller round dark gray area, a darker gray area. Okay, and that's 333 kilometers across, Mare Nectaris. All right, and at the western edge, you can just barely see some details. There's a crater called Beaumont, which is shallow, and you can just barely see it. I can. Oh, okay. I will zoom in, see what we got here, because the moon is going to stay out of the clouds for just a couple more minutes. Let's see if we can do this. So if we zoom in here one more time. Okay. Now you can actually see what I'm talking about. All right, now this is and you can see how disturbed the air is around the moon because there's clouds all around it. And right there in the center, I'm going to move it to the center right now. Okay, that little guy right there in the center, you barely see it there, that crater. That's called Beaumont. And it's actually right at the left turn. Wow, the left edge of Mare Nectaris. All right. So there's a dozens of things we can look for now. To the right of that crater, we have this one. Okay, which is actually a fairly good sized crater. It's called Fracastorius. Okay, and it's named for Girolamo Fracastoro is an Italian doctor and astronomer who lived in late 1480s to early 1480s to 1553. Okay, and that crater is named for him, and it basically forms the lower boundary of Mare Nectaris. Mare Nectaris, yeah. So coming back to the Terminator here, we can see some really deep shadows here, and I really enjoy these really deep shadows, frankly. And we have a number of really interesting craters here, and I think the one that we're looking at right now in the center, which has that, it's smaller, it has that sort of dark shadow in it. That's actually a crater called Tacitus, and it's named for Cornelia Tacitus, Roman historian. He's this little crater is only 39 kilometers across, but it has a very brilliant shadow. All right, and it's actually a crater which has got a fairly what's the word? Complex center. It's not a. It doesn't have a central peak that's very noticeable, but it's actually a crater that's actually pretty cool. And again, it's to the left of Katharina. Okay, remember Katharina is that one there, right in the center now. Katharina is below Ceres, and Ceres has been overtaken by Theophilus at the top there. Ted, yay, Tacitus! I'm a huge fan. All right, I think. Well, anyway, then we move down a little more here, and let's see what we've got. If we keep going down, all right, we'll see. Let's see now. I think. Okay. There and. Okay, I'm just looking for a few things here. And I don't see it, but I'm at. Sure, I'm going to try and. Well, maybe. Okay. All right. This crater over here. All right, which you see. This other complex crater has a central peak in it, right in the center. That's a crater called Piccolomini, which is like, hey, don't Piccolomini, you know. And it's actually named after Alessandro Piccolomini, an Italian astronomer from 1508 to 1578 when he was active. It's a crater that's 87 kilometers in diameter. And you'll notice that some of these complex craters don't have to be very large, for instance, to actually show a central peak. Some of them show central peaks, even though they're only clouds too. Well, even though they're only 87 kilometers or so across, and that's because the impact energy of the impactor was sufficient to cause the central peak. All right. Now, next to Piccolomini, to its left, okay, there's another crater right down below it. Okay, actually another pair. Okay, and that crater pair, first of all, the dark one that's kind of in the center there, right there, and it has another smaller one right next to it. That one right there in the middle, to the lower left of Piccolomini, is actually a crater called Rothman. All right, and it's Rothman crater. It's 42 kilometers in diameter, and it's named after Christopher Rothman, Rothmann, German astronomer, circa 1600 or so. But then there's one next to it, which you can see, and it's just a little bit to its left and lower. Okay, and that one down there is actually, I'll give you the name here in a sec. There we go. So I got it there. So just about the center there, just below to the lower left of Rothman, is one called Lindenau. And that's Lindenau, and Lindenau is an interesting crater because Lindenau kind of paves the way to the next one. Now that's 53 kilometers in diameter, and it's named after Bernard von Lindenau, German astronomer. And right to its left is the other one called, and I'm going to go there now, and you'll see it's sort of an irregularly shaped crater right there. See it? Right there in the middle. And that crater is actually called Zagut. Z-A-G-U-T. Zagut, named for Abraham Ben Samuel Zagut. It was a Spanish astronomer who lived from 1450 to 1522. See, there's a lot of people in history that made a difference, and you don't even know it. But the interesting thing is that little crater to its lower left, right? Right. Okay, so that little tiny crater, you see it there with the dark shadow in it, right in the middle there, about there. Let me just get that centered up again. That crater next to Zagut is another one that you would be interested in knowing about, I think. And that one, let me just make sure that I'm going the right direction there. Hang on one second, I'm getting there. Hold on. Yeah, okay, that crater right there in the middle, that one has an interesting name as well. It's called Celsius. That's right, it's Celsius crater, named after Anders Celsius in 1701, the Swedish astronomer. And of course, the Celsius scale is certainly named after Anders Celsius. So I think that's pretty cool that he's there. So we have a bunch of craters to deal with that are really kind of fun. And oh, come on, you clouds, you nasty old clouds! They always ruin our fun, don't they? So now if I just bring us down farther a little bit, let's go see what we've got here. Let's see if I can look at this stuff. All right. Now, that large crater you see right there, that's almost entirely in shadow, but it's right there, very dramatic looking. Okay. I think that crater is actually Stoffler. I think so. I think that's Stoffler. If Daryl's still with us, he can probably confirm that. I think that's Stoffler. Kind of hard to tell. May not be Stoffler. Yeah, okay. Well, I don't know. We shall see. Anyway, that said, I think that just staring at the moon and having fun tonight has been fun, and I kind of like taking you on a little bit of a trip across the moon. Oh, Daryl doesn't know either. Hi, Dee. Hey, there's Ronald. I see you there now. I didn't see you before. All right. Well, that's okay, Daryl. I think it's Stoffler, but I'm not sure. But on the offhand that it is Stoffler, that one right in the center, kind of just the big one, has a central peak that's just barely illuminated. That's actually 126 kilometers in diameter. I mean, that makes sense, and it might. Wait a minute. Let me see here. I'm trying to see if it's what I'm thinking it is. Oh. Okay, you know what? I take back my thought. That's not Stoffler. That's actually the crater Maurolycus. All right, and Maurolycus is a crater that's 114 kilometers in diameter. It's named for Francesco Maurolyco, an Italian mathematician who lived 1494 to 1575. And Daryl, I'm sorry. Daryl's like, my brain's running out my ears. Gets crazy. Anyway, that's still pretty fun. Actually, we like this stuff. Daryl, you wouldn't have it any other way. You like your brain running out your ears anyway. Because if it's not, then you're not enjoying yourself. I think you like to have your brain running out of your ears. So I'm impressed with that. That's good. Yeah, that's Maurolycus, and that's more like it. And then, because I was comparing it, and right to Maurolycus's direct right side, you see another pair of craters. Kind of, we just kind of put them in the middle. I will have that what do they call it? The ability to draw live on here. That's coming. I'm already working on it. And those two little craters near Maurolycus are actually it's actually Barocius. Barocius is this little interesting crater. It's 82 kilometers in diameter. And there's another one that's right next to it, and I don't actually have that one's name. That one isn't named. I mean, it is named, but I don't have its actual name. But that's what we're looking at. That's definitely Maurolycus. All right, cool. Now I get that. That's good. Very good, yeah. All right, so that's that, and now let me go down. And what's next? What else do we have? Wow. Well, now we have something else. We got more craters down here, which is pretty cool. I'm gonna go right, put that in the center there. All right, so we got basically, we have one fairly good sized crater there, and I'm trying to figure out which one that is. Let me just go up a second. Right, stop. Maurolycus, and okay, so then we got Maurolycus and those guys. Yeah. Okay, so that must be. So right there in the middle, that one is the one that's almost completely dark, but it has a little rim showing up. That's the one that I'm looking at now, and I think that one. I'm looking now. I don't want to say the wrong thing, but I've got clouds that are causing all kinds of havoc. Let me see. What's that one? I'm looking at. I think it looks like Cuvier. Cuvier, which is a crater that's 75 kilometers across, named for Georges Cuvier, French natural scientist. He was also a paleontologist, which is kind of interesting. And then we're at the bottom of the moon. Well, that is the edge that we can see, right? And we're not going to be able to easily identify stuff here. But I can tell you this much. I can tell you what that crater is that you see kind of fuzzing in and out there. See, we got a couple of them. We have two craters there that are near the bottom there, like that. Okay, one's in the center now, and you can see it's in shadow on its upper right side. Okay, and that crater is actually a crater called Manzinus. Okay, and it's named for Carlo Antonio Manzini, an Italian astronomer who lived from 1599 to 1677, when technology just became so much better. And of course, that's a lie. And above Manzinus, right up there, okay, that crater is actually, that crater, let me find that crater. Above Manzinus, that's the crater Mutis, okay, which is 77 kilometers in diameter, and I'm going to try and, yeah, it's just below center. Let me just move it up a little more. Okay, so that's right about in the center. And that's 77 kilometers in diameter, and it's named for Vicente Muth, a Spanish astronomer, circa 1673. And there's our Terminator. We kind of went over all the main features of the Terminator tonight, because we could. We don't necessarily get a chance of doing that often because, we don't have the availability of this telescope for that many times. We have to look at other things because our schedule is very important, you see. But anyway, I don't know what else to do other than to curse the clouds. But my old standby here was the tour of the Terminator with the moon. I thought that was kind of cool. But let me go back and just do a survey of the sky for 1 second and see if there's anything we can do about the clouds. And see, the moon is placed such that, well, I know what we can do. We could go do one other thing, because now that we're done with the moon for tonight, I'm going to take us to one more item up for bids here on The Price is Right. That's right. And that is going to be, with the moon out, unfortunately, it's not good for any kind of deep sky stuff. So let's go over here and go visit our old friend Jupiter. Okay, so let's get Jupiter in here. And here we go. Say bye-bye to the moon. Jupiter happens to be out of the clouds at the moment. So I figured, hey, we can do it. We can just try and find a few things, All right. Oop, and it went by, but it'll be coming back. That's what I like about this telescope. Look at that. Talk about alignment. I mean, it's dead center. Can't do any better than that. I like it. Let's take a look at how it looks. Oops, sorry, my the thing that wasn't dead center was my okay, I think we got a focus issue there. The sky's unsteady, and sometimes you have to refocus, actually. So let's do this. Let's see what we got. Okay, so you can see that it's really an unsteady sky. Wow. Well, you can see the turbulent air cells moving all across the sky. Usually we can see cloud bands and a great red spot if it's there. But tonight is a rather poor night to look at Jupiter, unfortunately. I mean, but right now the great red spot's not visible, as far as I can tell. But as far as moons, well, we can figure those out because we got a rather interesting setup tonight. Let's set the camera to show those, shall we? So what we'll do is okay, there we go. And now when we come in, here you go. Now you see that line of moons right across are the Galilean satellites. On the left, we have the next world that we will visit when we visit Jupiter, and that will be Europa on our left. To the right of Jupiter is the closest moon to Jupiter, full of sulfur and so forth. I was going to say another phrase I learned as a kid, but I'm not going to say it because it had a bad word in it, and I don't want YouTube to chastise me for 90 more days. To the right of Jupiter, the first there is Io, of course, the closest moon to Jupiter. And then we have next to it Ganymede, all right? And then farther, and Ganymede is actually the largest moon in the solar system. And then to the right of Ganymede, out there in the distance, is Callisto. It's the outermost Galilean moon. pretty interesting. I like looking at these because it reminds me of how much we know about physics. It all makes sense. Because we look at these, and when we look at like let's look at Callisto for a minute. Let me just get us over to Callisto. So first things first. Yeah, Callisto is now roughly centered. It's to the right of center. All right. Now, Callisto's 4.6 astronomical units from us at the moment. All right, and it's actually quite a it's fairly good size, I would think, as a moon. Okay. And its diameter is 4,821 kilometers, which is 0.3 Earths. Okay. But its mass is only 1/100th of the Earth, so it's actually 2/100ths of the Earth or so. So it's actually a very lightweight moon, probably an ice world. So it's pretty good. When we look at the if we look at the density, its density is defined as mass per unit volume, and the mass per unit volume on Callisto is 1.84 grams per cubic centimeter. All right, so mass per volume, cc, cubic centimeter is a volume. And when we look at Callisto, it has a 1.84 gram per cc density, and water is 1. So it's slightly heavier. Its gravity is about a tenth of the Earth's. It's 0.126 g. And it goes around Jupiter in 16.6 days. So that's kind of cool. And being that far away, okay, it's actually it's 1.9 million kilometers from Jupiter on average. So that's a good distance. It is the outermost moon, though, so that's kind of neat. So this is Callisto, and Callisto, of course, is the outermost moon of Jupiter. Now, when we look at the next one, we look at Ganymede, and Ganymede is this one here. It's the central one in the center of the screen now. You notice that Ganymede looks a little bit brighter than the others, and that makes good sense because Ganymede's actually bigger than all the rest. So that's kind of neat. That's a very big moon, so to speak. Its diameter is 5,262 kilometers across. That's 0.4 Earths, almost half the Earth in diameter. That's kind of a big size. Its density is almost 2 grams per cc. That is to say, with water being 1, it's twice the density of water almost. And its gravity is 0.14 that of the Earth. So it goes around Jupiter in 7.16 days. So, and it's a lot closer than Callisto. So it's pretty good. It's 1.1 million kilometers away from Jupiter. So for that, I would say that we're looking at for the biggest moon in the solar system. I think that's pretty cool. Now, and it's the third closest of Jupiter's large Galilean moons. That distance I was telling you before, that's about 665,000 miles from Jupiter. And that takes it 7 days to go around Jupiter at that distance. All right. So what's interesting is these moons, Callisto, Ganymede, and Io and Europa, are in a resonance where it goes, for instance, for each orbit of Ganymede here, Europa goes around Jupiter 2 times. All right. I'm sorry. Yes, and Io goes around Jupiter 4 times. All right. So that's the 1-2-4 resonance that we've talked about in the past. That happens when you have moons like this. They settle into this pattern, and it's a 1-2-4 resonance. Now, Ganymede's actually bigger than Mercury, all right, and it's the largest moon in the solar system, as I said. And that distance, by the way, is 3,280 miles. That's the diameter of Ganymede. Now, I said 5,262 kilometers, but putting it in terms of miles for you, and that's basically the largest diameter. The moon's just over 2,000 miles across. So, but Ganymede's neat. Okay, the surface it's got these dark and light modeling regions, and we know that the dark regions are heavily cratered, which tells us that it's an ancient surface with ancient origins. All right, and then there's grooves in there on Jupiter's Ganymede. It's really cool, and they think that Ganymede is what's called highly differentiated. The moon was really once hot enough that its ice was completely separate from its rock and metal, and intense heating must have melted the ice, and maybe an internal flood that might have lasted hundreds of millions of years might have happened too. And then where the warm water was actually, butting up against the frigid cold of space, that icy skin formed and thickened over time. And then deeper down, the mantle contained materials that were more like the metals, and that was the differentiation where the hot, dense stuff fell more and sank toward the center. And that's an interesting set of facts about Ganymede. But the surface has really got all these grooves in it, and those grooves tend to be from melting and refreezing and so forth. And so it's just an impressive surface moon. Now, moving further, if we go to the left toward Io now, we look at Io. Io's in the center now, and there's a cloud crossing Jupiter, and you can see that our moons have been obliterated. But we know Io's there, so we'll talk about it. Now, Io's probably the most dramatic moon that Jupiter has, because it's surrounded by a torus of sodium ions that erupt off its surface, and there's many volcanoes on Io. Io has these massive plumes that go out into space, and these plumes are sulfur laden, because Io is like a little ball of molten sulfur, right? And it's also the innermost of the Galilean moons, and so its orbit is only 262,000 miles in diameter, actually radius. So it's double that. So that's pretty small orbit, considering that Jupiter itself is 89,000 miles across. And it goes around Jupiter once every 1.77 days. All right, and it's 2,263 miles across, which is 3,642 kilometers, if you care about the actual numbers. But the surface of Io doesn't show any craters at all, any impact craters, I should say, and that's because the geology is dominated by volcanic activity, which constantly reshapes the surface. So, that said, Io is a real interesting planet. I actually built a radio telescope to listen to Io. And what's neat is when I listen to Io, you can actually hear the sounds of that sodium torus around Io. And Jupiter, in Io's orbit, there's actually this torus, a donut of ions and atoms that were ejected from the surface of Io. And as Io goes around Jupiter, they come back down to the surface of Io. But man, it's just a molten sulfur surface. and the on Io there is a crater that's a volcano crater that's actually constantly molten, and that's Tupan Patera. And so it's Tupan, Tupan, Patera, Patera. So Tupan Patera, and you'll see that that's just got some unbelievable features. I mean, I'd love to just go to Io and see what it's like. It's got a very hot interior as well. Now, you may ask, well, why has it got such a hot interior after all these billions of years? Well, the truth is, Io is being pulled and flexed by Jupiter, plus interactions with the outer moons, tends to like just massage it gently in every orbit, and that tends to heat it up. You know what it's like if you get a massage. As you get a massage, your skin heats up where the massage is being given. So that's a very interesting feature of Io as well. See, so I think that that's very interesting to consider. So moving over to the next moon that was there for a second. Now we're at Europa. And Europa is the most fascinating moon around Jupiter. Io is the most dynamic. Europa is the most fascinating. Europa is really cool because this moon is just, I have to tell you, this moon is probably the most interesting moon in the entire solar system next to Enceladus. And the reason I say that, and Enceladus is around Saturn, the reason I say that is because of the fact that this little guy, which is 3,122 kilometers in diameter, which is just over 1,900 miles, may have an ocean under its icy crust that is 60 to 90 miles deep, and these are this ocean is something that might actually be able to harbor life. And you might say, well, how could it? Look, there's no atmosphere. Yeah, that's true. But this ice has sealed the ocean underneath the surface for billions of years. So any creatures that have that did exist and do exist under the ice, if possible, will have adapted to the dark, which may not be so dark. I mean, there are going to be areas where the ice is thinner than others, and the light from the sun might penetrate a little bit. It still doesn't mean that there's going to be photosynthesis going on. Okay, because if there's photosynthesis going on, then it means that the sunlight is essential for life, and we can't depend on that at Europa. We probably have chemosynthesis going on, more akin to what we find at the black sulfide chimneys on Earth, at the off the Juan de Fuca Ridge and the Mid-Atlantic Ridge, black smokers down there. That's probably more what it's like, and I think that that's pretty cool. Yeah, I agree, Ted. I think that this is a really interesting alignment. So you know what I'll do? I'm going to do this. Now that we know we're talking about the moons, we know what we're talking about with the moons, I'm going to do what Ted suggests. I'm going to take a photo of this scene, just like this. So it's going to be a little small here, but here we go. Let's take a photo. It'll be, let's do this like this. Let's say, well, we're going to do it. We'll do this, right? All right, we got a little cloud, so let's just do this photo. It's going to be 5 seconds at ASA 50. There we go. And so here's our photo. So that's our photo. So it's going to look like this. And at ASA 50, it's there we go. See, now we got that alignment. Okay, we have Callisto, Ganymede, Io, and Europa. Right there. Very nice. Thanks for that suggestion. I thought that was kind of cool. Good suggestion. So, that said, I'm going to unwind myself because I got myself wrapped up in my headset cord here. But yeah, oh man, we're getting clouded out, folks. I'm sorry, but that's okay. You know what? We managed to squeeze out quite a bit. Anyway, and I do have to go to bed early because I have tomorrow. I have to film season 5 of What on Earth. They came to set up tonight, and I told them that I'm going to be streaming tonight. So they'll be back tomorrow to do all the stories. I have like 11 stories to do for this new season. So I have all the stuff out there. It should be pretty good. Oh yeah, I wish, Ted, I don't drink coffee. What I do though is I do drink Coca-Cola, which probably isn't the best thing. Coffee's better for you, I bet. But anyway, I think this is great. I want to thank you guys for coming and hanging out with me for a little while. I look forward to doing this again. I guess Amanda was busy and couldn't come with us or come out with us tonight and play. But I know that it'll be she'll be back next time for sure. So that said, I just want to thank you guys for coming. I had a good time with you tonight, and I hope you enjoyed the beginning of the evening where we looked at the asteroid Ceres and Vesta, and then later we looked at a cluster. We also looked at the moon, did a tour of the Terminator, and then checked out Jupiter and all its moons. So I hope that was enough for you tonight, but never enough for me. I can always do more if Mother Nature were to cooperate. But hey, like I said, I enjoyed your company, so thanks for coming, and I will see you next time. Don't forget, keep looking up. Good night.